Welcome back to Statistics for Business Research and the continuation of the regression results demonstration. Now, when you look at, as we indicated earlier, we said that you can also check multicollinearity by looking at the variance inflation factor. And we expect that the variance inflation factor should not be more than 10, or the tolerance should not be less than 0.1. And in this case, we are going to, the next highest is the adult illiteracy. And if we recall, the two were highly correlated. So if one of them is not the variable of interest, then we need to drop that variable. So for example, if we drop this, we will drop human development index and see how the results behave. So let's drop human development index and see how the results will behave. So let me go back to my estimation analysis, go to regression, come to linear regression. Now we are dropping human development index and see what will happen to the results. So we click OK. Now if you click the results, now the new model shows that the adjusted R square is 0.89, it's about 89 points, it's about 20%. Now our ANOVA is still significant, meaning that there's a joint significance. Then we come back to our variance inflation factor. Now you see that the variance inflation factor of adult literacy has reduced to 3.284. So there's a very low variance inflation factor, and the tolerance is very high, meaning that there's no multicollinearity. Okay. Now, once we get these results, we can then move on to the regression to explain the results. The regression reports two betas. We have the unstandardized coefficient and we have standardized coefficient. In fact, the unstandardized coefficient are the normal regression coefficients. Okay, and the standardized ones are frequent standard deviations. They have been standardized, it's standard deviations. And if you look at this regression result, there are something that I want you to take note of, because at times students tend to doctor some of the results. Now, if you come here, the sum of squares here and the residual sum of squares of the regression and the residual sum of squares, when you sum it, you get this total. Now, when you divide this by the degree of freedom, you get this. When you divide this one by that, you get that. And when you divide this one by this, you also get this. Okay, so you need to know the relationship between them. Now, when it comes to the results here, as we indicated, when you divide the coefficient on standard beta by the standard errors, it gives you the t statistics. When you divide the adult illiteracy by standard error, you get the t statistics here. When you divide this by that, you should get this one. So when I divide this by that, I'll get this t. When I divide this by that, I'll get this. Okay, when I divide this by that, I'll get that. And for t to be significant, for a coefficient to be significant, its t value should be greater or equal to 2. Okay, once we get t values to be greater than or equal to 2, you see that its probability value will be likely to be less than 0.05, and that would be significant. So, because in most cases, students tend to doctor the result or try to make some changes to the result, and that you see at times, if they expect adult illiteracy to have a positive effect on life expectancy, they themselves, when the result says negative, then they will delete this one. But once you delete it, the t statistics will expose you, and then you also, the standardized beta will also even expose you. So what we are saying is that if the coefficients are negative, the t will also be negative. If the coefficients are positive, the t's will be positive, and vice versa. So we need to be very careful as that. Now the researcher will want to use the unstandardized beta when the researcher want to do prediction. The unstandardized beta is a good one to use, and that is what we use to formulate the regression equation. Okay, so the unstandardized beta is what we use for the regression equation, and it's used when the researcher want to predict. Now when we come here, the standard beta will be used when we want to compare among the independent variables which one has a greater influence on the dependent variable. So we can compare between this and this, and that you can compare among them. But here we cannot compare because they don't have the same unit, they are of different unit. Okay, age is measured in years. Interest for corruption is an index, we don't know what is, it has maybe no unit. And then quality of life, they also have not unit. But when we standardize it, they all get the same unit, and they have been standardized, so they can be easily be compared and say that. So from here, if you look at this, the one with the highest coefficient among the apart from the constant is level of intolerance, okay, followed by quality of life, followed by adult illiteracy. But when you come to the standardized, you realize that the adult illiteracy, though it's negative, has higher influence. Okay, though the influence is negative, its value has higher influence than any other variables. You can directly compare them. Here we cannot compare them because age and index, their units are not the same and cannot be compared. So this one can be directly be compared. So if you want to look at which one has a higher influence on the dependent variable, then we look at the standardized beta. Okay, we look at the standard beta. And don't forget, I said that there's no way that the sig value here will be less than 0.5 if the t value is not 2 and above. So if the thing is insignificant and you want to change it and make it 0.00, you'll be exposed from here. Okay, this one will show you that what you have indicated here is not true. Okay, so once you have that, you can check the results. Okay, you can check the results and see. So from here, we can interpret the results using the standardized beta as a 1 unit change in adult illiteracy cause negative 0.366 change in life expectancy. So in that order, so we can do that interpretation. But here we are seeing them as a standard deviation. So 0. Negative deviation from adult illiteracy will cause one standard deviation will cause this deviation. So one standard deviation from change or deviation from adult illiteracy will cause negative 0.67 deviation from the life expectancy. Okay. So when you get the result, we need to look at the other diagnostics first. Look at the model. Look at every aspect. So when if they don't satisfy those assumptions, don't try to interpret the results. Okay, don't try to interpret the results. We expect the residuals to be approximately normally distributed, and here you see that it's not too bad. When you look at the residuals, it's not too bad even here and that. So it means that the model that you have developed is a good model and can be interpreted. So you look at the regression result, and then you can see how it should be reported from your manual. So when you go to your manual, you see how those things are reported. Okay. Thank you. We also have to take note that we are not going to discuss this thing again in class. We are going to handle your concerns regarding what you have discussed. So you need to go over this video again and over until you get the concept. Thank you very much.